So members, we are getting started. Welcome all of you. We are looking at the geography. Our lesson has begun. Those who were here in the first batch, type in the chat if you can see my screen. So members, we are getting started. Welcome all of you. Okay, all of us can see my screen. That is wonderful. Okay, so today, I still say welcome to this online lesson. It's still me, the same teacher Kakuru Benard, who is going to lead you through this online class. And so we are continuing with rock weathering. In the first lessons, we heard about weathering generally. We defined what physical weathering is, chemical weathering, and the biological weathering. So today, basically, we want to look at the physical weathering processes. By show of hands, who can tell us what physical weathering processes are and some examples? Raise your hand and give a suggestion. No one is suggesting physical weathering processes and some examples. Okay, so before we dive into the whole process, let's look at introduction. Who can raise up a hand and read for us this introduction? Raise your hand and take us through this introduction. Yes, Emmanuel.
As already defined, physical weathering is the mechanical disintegration of rocks into fragments, rocks within rocks, as in various ways as shown below.
Okay, thank you very much. So as shown below, we want to look at different ways how weathering takes place. But before that, I want us to watch briefly this video and then we move on.
Mechanical weathering caused by thermal expansion and contraction. In areas with a large diurnal range of temperature, the rocks are heated up intensely during the day and cool to a low temperature at night. This results in an alternate expansion and contraction of the rocks. Thermal expansion and contraction results in three forms of mechanical weathering. They are block disintegration, granular disintegration, and exfoliation. Block disintegration occurs on rocks with cracks. Repeated expansion and contraction enlarge the cracks. Large masses split away from the main rock along main cracks. Rock breaks into blocks. Granular disintegration occurs on rocks with different minerals. Since different minerals expand and contract at different rates, rocks which are made up of a variety of minerals are under stress during alternate heating and cooling. For example, at daytime, mineral A expands faster than the adjacent mineral B and pushes them apart. During nighttime, mineral A contracts faster than the adjacent mineral B and becomes detached. Repeated expansion and contraction causes all mineral grains to loosen and detach. Rocks break off into grains. In time, rocks disintegrate into small pieces. Exfoliation occurs on a uniform mass of rock. During daytime, the outer layer absorbs more heat and expands more than the inner layer. Concentric cracks develop. At night time, the outer layer loses heat faster and contracts more than the inner layer. Radial cracks develop. Repeated expansion and contraction causes the outer layer to peel off. Rock breaks into slabs. A new surface is exposed to heating and cooling.
So far you have seen a little introduction about that. Next, let's now briefly talk about exfoliation process. Who is ready to read for us what you can see on the screen? Who is ready? Yes, Gilbert.
This process is caused by repeated heating and cooling of the rock surface due to high insolation and terrestrial radiation. During day, the rock surface is intensely heated by the incoming solar rays, thus making it expand and develop cracks. At night, temperatures rapidly fall to cold levels due to outgoing surface radiation, and this makes the rock to contract rapidly, thus cracking the rock.
Okay, thank you. So you can continue here.
The repeated process of rock expansion and contraction created by wide temperature fluctuations makes the rock cracks widen to a surface centimeters thick and consequently begin to peel off into screws, rock debris. After the peeling off of the outer rock layer, a new rock surface is exposed to the atmosphere in form of oval
Okay, thank you for taking us through that. Let's have this video again.
Hello and welcome. In this video, we are going to learn about the various types of physical weathering. Before we continue, however, we should remind ourselves about what weathering means. Weathering is the process whereby rocks on the Earth's surface are broken down and worn away by physical, chemical, or biological forces. As I said, in this video, we will be focusing on the physical forces. Physical weathering comes in two main types: frost shattering, also known as freeze-thaw action, and exfoliation, also known as onion skin weathering. You should already be able to identify what rocks affected by each form of physical weathering look like. Frost shattering causes rocks to be fractured into shards or pieces, while exfoliation causes rocks to peel, hence the onion skin name. Let's look a little bit closer at the frost shattering process. Many rocks have cracks and breaks in them. If any water gets into those cracks, it can quite easily break the rocks into smaller pieces. This is essentially what is needed for frost shattering to take place. Water from rain or melting ice fills a crack in a rock. At night, if the temperatures get low enough, the water freezes. As water expands by roughly 10% when it freezes, it can force the crack in the rock to widen. The key to understanding any kind of weathering, however, is realizing that it is a process. Frost shattering won't break a rock apart in one night. It can often take many years of repeated freezing and thawing for that to happen. Eventually, however, the water wins and the rock is shattered into multiple smaller pieces, like we can see in these examples. Because frost shattering requires temperatures cold enough for water to freeze, you're unlikely to find the effects in many climates around the world. The most common locations, therefore, for this process are areas of high latitude, like the poles, which are cold because of lack of direct sunlight, and areas of a high altitude, like mountains, because of the cold temperatures created by height above sea level. The second type of physical weathering is exfoliation. As you can see from the diagram, this is a process that starts when a rock is exposed to extended periods of sunshine during the day. This sunshine heats the outer layers of the rock, which in turn causes these layers to expand. At night, the rock gives off all the heat absorbed by the outer layers, causing these layers to contract. For this expansion and contraction to break the rock, it needs to occur as often as possible for as long as possible. Eventually, the outer layers of the rock will start to crack and joints will form in the rock. Over time, these layers will then crumble or slide off the rock layers, leaving behind rocks that look like these. In order for exfoliation to occur as fast as possible, the process needs to take place somewhere where it gets extremely hot during the day and extremely cold during the night. In other words, desert regions. Let's quickly summarize what we have learned. Firstly, physical weathering requires temperature changes to take place. Secondly, physical weathering comes in two forms. Thirdly, frost shattering involves the freezing water shattering rocks. And lastly, exfoliation sees rocks peel away due to extreme temperature changes and expansion and contraction. And that's it for this video. Thank you for watching. I hope you found it educational and entertaining.
Mechanical weathering caused by thermal expansion and contraction. In areas with a large diurnal range of temperature, the rocks are heated up intensely during the day and cool to a low temperature at night. This results in an alternate expansion and contraction of the rocks. Thermal expansion and contraction results in three forms of mechanical weathering. They are block disintegration, granular disintegration, and exfoliation. Block disintegration.
Members, are we fine? Are we finding it okay? Text in the chat. If yes, we continue. Type in the chat, yes, we are on track.
Occurs on rocks with cracks. Repeated expansion and contraction enlarge the cracks. Large masses split away from the main rock along main cracks. Rock breaks into blocks. Granular disintegration occurs on rocks with different minerals. Since different minerals expand and contract at different rates, rocks which are made up of a variety of minerals are under stress during alternate heating and cooling. For example, at daytime, mineral A expands faster than the adjacent mineral B and pushes them apart. During nighttime, mineral A contracts faster than the adjacent mineral B and becomes detached. Repeated expansion and contraction causes all mineral grains to loosen and detach. Rocks break off into grains. In time, rocks disintegrate into small pieces. Exfoliation occurs on a uniform mass of rock. During daytime, the outer layer absorbs more heat and expands more than the inner layer. Concentric cracks develop. At nighttime, the outer layer loses heat faster and contracts more than the inner layer. Radial cracks develop. Repeated expansion and contraction causes the outer layer to peel off. Rock breaks into slabs. A new surface is exposed to heating and cooling.
Okay, members, that's what we can say about physical weathering. Now, let's move on to the next slide. Now, here, exfoliation has been well explained. Yes, can I hear from Benjamin? I mean, Ronald? Unmute. Ronald?
Yes, sir.
Yes.
If we are doing this part of weathering, is it necessary for us to put some drawings where necessary if they ask a question about weathering?
Yes, you have to make drawings. You have to make drawings. Yes,
okay.
Drawings are important.
That's what I wanted to know.
Yes, so
Okay.
you have looked at the exfoliation that the outer rocks wear out, then you remain with the surface. So we are saying that this one happens because of too much heat during the day, contraction during the night. So it will make the outer rock, the outer rock to wear away and then remain with the inner surface. You can see that one. So here, the outer part is wearing away, then you remain with that inner surface.
Okay, okay.
Okay, you can mute and then maybe I will get someone else. If you have a question, please raise up your hand. So that is it, you can see. Then the next process is called block disintegration. Who can read for us block disintegration? Yes, Pamela. Pamela?
This occurs in areas where there are jointed rocks which experience extreme temperature fluctuations during day and at night. The high temperatures during day and cold nights lead to rapid expansion and contraction of rocks, thus making the rocks to fracture into rectangular blocks, a process known as block disintegration. This type of weathering produces granite tores or incel bags. These granite tores are incel bags are of two types, i.e. cartilated tores and finger type incel bags.
Okay, thank you, Pamela. So here we are looking at block disintegration. It occurs in areas where the jointed rocks are experienced extreme temperature fluctuations. That means that it is hot during the day, then cold during the night. So when this happens, we shall have such features produced. So here is an example of the granitic tores. These are more examples. Examples of such, some of them in East Africa can be seen in Ihonga, Muri, Iresi area of Kakamega in Kenya. That's why you can see such granitic tores in East Africa. Let's move to another weathering process, which we call granular disintegration. Who is taking over this? Raise your hand and take over the slide. Yes, Mia. Mia.
Granular disintegration takes place almost in the same way as exfoliation, except that in this type, rock disintegrate into small particles called granules, and granular disintegration is produced in two ways.
Okay, let's see those two ways. You will continue to read below. Yes, continue. The first way is that by
differences in thermal expansion and contraction, Some rocks are composed of minerals and particles that respond to temperatures differently. If a rock is, for example, made up of white and black particles, it will absorb more temperature than the white particles, and both will expand at different rates. The same applies when the rock has got minerals that expand and contract differently with thermal heating. This will cause strains and stresses within the rock and to break up into its granules.
Okay. Here, we are looking at the two processes under granular disintegration. We have thermal expansion and contraction. So here, we are saying that some rocks are composed of minerals and particles that respond to temperatures differently. White surface, okay, like we can say, rocks which have bright surfaces, these ones will reflect light and therefore they can't absorb too much heat to be broken into particles. But black particles will absorb heat, and then due to contraction and expansion, they will start to break into smaller particles. So let's see, when you look at this rock, it is a bigger rock, but then around here you see these are particles that have fallen off from this bigger rock. Do you get the point? That is one way, and you can call that one the granular disintegration. Let's look at the second part, frost heaving. Who can read about frost heaving? Frost heaving. I will not read anything on this slide. It's you to participate. Vivine.
Yes.
Yes, take it on.
Okay. Frost heaving. This type of granular disintegration is common on ice-capped margins where freezing and thawing occur. It also occurs in porous rocks such that when temperatures are high, in brackets during the ice melts and water enters the rocks. When temperatures drop below 0 degrees Celsius, this water freezes within the rock particles and expands, hence detaching these particles apart. The rock crumbles into small particles, in brackets, granules.
Okay, thank you. So when we are saying that this process happens in those areas which experience freezing. In East Africa, you can talk of on the tops of Mount Rwenzori, Kilimanjaro, and Mount Kenya. So here you find that when it rains, water gets into the cracks. Then when freezing comes, now the water becomes solid. We call it ice. And then as it becomes ice, solid, that means that it will start expanding the cracks. So as it is expanding the cracks, now the rock will now change into small particles. So you can read for us this paragraph.
Teacher me?
Yes.
Frost heaving leads to the formation of stone polygons or patterned ground seen in valleys. For example, Teleki Valley on Mount Kenya and also on Mount Rwenzori. Alternatively, frost heaving is called congelitabation.
Congelitabation.
Thank you.
Yes. Yes. So that's where you can experience, or that's where we can find live examples of frost heaving in East Africa. Any question? You can raise the hand. Okay, let's go to the next process. Frost shattering. Who is taking over frost shattering? Raise your hand and take over frost shattering. Okay, I'm picking new people. Ime, unmute.
This is a type of weathering experienced in areas that fall below 0 degrees Celsius, and in East Africa, these are mountains peak of Mountain Rwenzori, Mountain Kenya, and Mountain Kilimanjaro. During the day, water enters into the cracks of the rocks. During the night, this water freezes and exerting pressure within the cracks. Water in such mountains freezes almost every night and then thaws the next day. It is said that water once frozen expands by approximately 10% its liquid volume. It is the expansion in the cracks that makes the rock particles within the cracks to break off as screws and rock to disintegrate.
Thank you. That is frost shattering. Let's continue to first explore about it. So when you look at this type of weathering, the other one we called it congretabation. Now this one is normally called the congrefraction. Still, it is almost the same as the frosty heaving, but here basically we are saying that this one happens in those places which have temperatures that fall below 0 degrees Celsius. So during the night, the water freezes, and when this water freezes, it exerts too much pressure within the rock. And so this will make the rocks to expand, because also the liquid volume has expanded by 10%. Its volume has expanded by 10%, and this will lead to expansion of these cracks within the rocks. So when you look at this drawing, water is now within the cracks, but then here you see that there is an increase within the cracks, and therefore with time you will find that the rock is also breaking. Okay, those ones who are asking messages in the chat, I've given you the link to senior 5. I've given you the link to senior 3. You can join. They are there in the chat section. Winnie, can you finish your statement down here? Winnie, raise your hand again, and then I ask you to unmute. I see Winnie is off. Okay, Ronald, read that statement below and we proceed. Ronald. Someone is asking meaning of screezes. Okay, screezes, these are like rock particles that are detached from the main rock. It is a geography terminology. Okay, let's move to the next. So we are saying that this type of weathering is also called congefraction. It produces angular screezes. You can call them rock particles that may cover extensive areas, which are called forcima. This can be seen on Batia and Nerion peaks on Mount Kenya, Upper Mbuku Valley, around Margarita, Stanley, and Baker's peaks on Mount Rwenzori. So when you look at this part here, these are the ones we are calling screes, angular screes, because they are got from the main mountain, so they are transported down slope. Next is pressure release. Someone to take us through the pressure release. Make sure you leave this lesson when all of you have read something. Caroline, Elvis, you read next. Caroline, take us through.
Yes, pressure release. Pressure release in bracket unloading process. This occurs when the overlying weight on the parent rock is removed by denudation, especially soil erosion, thus causing the underlying rock to be released. When such weight is removed, rocks begin to expand and develop curved joints parallel to the rock surface. These joints widen and deepen and eventually facilitate rock breakdown. It occurs on exposed batteries, sills, and dikes, and can lead to the formation of icebergs.
Okay, thank you. Let's first look at this drawing. Can you finish up this statement and then we understand the drawing?
Pressure release process occurs in the region of poor vegetation cover where there is severe soil erosion. Examples can be witnessed in Turkana land, Karamoja region, and Ankole Masaka corridor.
Caroline, you are off.
Teacher, I'm reading.
Okay, here we are looking at pressure release, that this process now occurs in regions of poor vegetation where there is severe soil erosion. Now you find that you have maybe it's like a hill and then you have too much vegetation covering there. So it means that with time, soil erosion is going to erode the vegetation on top. And once this vegetation is eroded, now you will remain with a new rock inside. This new rock inside, when it is exposed to the outside environment, it is going even to develop some cracks, and these cracks may expand. So here we are saying that examples can be seen in Turkana land, Karamoja region, and Ankole Masaka corridor. Others we have Maganjo in Kampala, Mwanza, and Iringa. Other examples can be traced in Serengeti and Rukwa region of Tanzania. So this is where you can experience pressure release. So the drawings are here. Those who are asking drawings, these are the drawings you may need to give when you are asked in the exam or when attempting such a number. Next, Elvis, you are the one to take on this. Elvis, unmute.
So, crystallization. This is one of the physical processes of weathering in which some rocks may absorb salt water. This salt water will later collect in the rock cavities and pores. This water may later start to evaporate and hence salt crystals will begin to form. As these salt crystals grow big and expand in size, the exert pressure on the
Are you done? Elvis, we can't hear you. Elvis? Edgar, can you finish up this?
Surrounding rock particles, hence making them peel off areas of
Edgar?
Surrounding rock particles, hence making them peel off. It is a common process in arid areas and coastal areas of East Africa.
Okay, so let's have explanation on this. So here we are saying that the crystallization as a process, you find that the salt particles may fall on a rock. We are saying that some rocks may absorb salty water. So when this salty water lands on a rock, it may start to expand in the in what we call the joints, or call them rock cavities. So once it solidifies there, it starts to expand these cavities or the joints. So when you look here, these are salt evaporates here. And then this side, you see, it has now expanded the rock cavities. So the rock cavities are like holes, they have expanded. So we are saying that it is in East Africa, it is located around Lake Katwe, Lake Nyamunuka, Lake Kasenyi in Western Uganda. It is also common around Lake Magadi, Natron, Nakuru. These areas are really having salty lakes. So you may not find this process in areas which are not having salt lakes or salty water. Anyone with a question, you can raise your hand or type in the chat. To end the part, you are reading the next slide. To end the part, let's look at organic activity.
Organic activity.
Yes, to end the part.
This is a physical activity of biologically. Organic activity. This is a physical activity of biological organisms, namely plants and animals. Plant roots searching for minerals and water grow into the rock. As the roots increase in size, they wedge the rock part. Burrowing animals further break down the rock by moving fresh minerals to the surface and underground rocks where they live.
Thank you to Pate. That is okay. So here, remember in the other sessions, even we have been looking at the influence of living organisms in regard to weathering. So this is because of plants, animals, basically living things causing physical weathering. So you remember last time we looked at things to do with termites, plants, earthworms, such animals. So etc. You can see someone to read for us there. That's that slide, top left.
Wild game and large domestic animals contribute to the physical rock disintegration as they trample on the ground in the course of their movement across the large land.
Yes, you can see such animals. So we talked about these animals, leopards, these elephants. Now you can see when cows are going to maybe to the water points, you see what they can cause on the ground. All that is physical weathering. Yeah? So someone to ask questions, etc. Raise your hand. So now we have seen at least physical weathering processes. Any person with a question? If there are no questions, let's proceed. So we have seen that the different physical weathering processes, and now here I'm leaving an activity which I will as well put in the Google Classroom. Even these notes are already in the Google Classroom. Please go ahead and access them. Then I'm going to put this assignment. Go ahead, attempt it. Read at your own pace, understand the physical weathering processes, then write somewhere, upload your work so that I'm sure that you understood the physical weathering processes. So basically, to wrap up everything, in the questions, someone is saying, okay, I'm coming to respond to those ones in the chat. Okay, so basically today we have seen that the physical weathering processes, they include exfoliation, block disintegration, granular disintegration, frost shattering, pressure release, crystallization, and organic activity. So everything here has been well elaborated. Tupate, you have a question?
Teacher, how can you access the Google Classroom?
Are you in the WhatsApp group?
Yes.
Yes, I'm going to post the code again. Senior 5, okay?
Thank you.
Yes. Right now. Yes, so our next topic, we shall look at the chemical weathering processes. So let's go ahead and read ahead on chemical weathering processes so that when we meet next time, you are aware that when I talk of carbonation, this is what it means. When I talk of hydrolysis, this is what it means. So someone is asking, how can I join the WhatsApp group? I've shared the link in the chat. Some of you are not seeing it. Can someone reshare the link? So I'm putting the link for senior 5 is there. Tap on it. So thank you for listening and for your active participation. Hoping for the best in the next lesson. Go ahead in the Google Classroom, access these notes, read at your pace. I know these notes are good for you to enjoy. Love geography to your best. Any other question? I think if there are no more questions, have a great evening.